Okay, let's start. Hi, I'm Gil. Thanks for coming for today's webinar, which is going to be an interesting experiment. I'll try to do it a bit interactive today. We'll see how that goes. And what we're going to talk about is creating a task plan, and we'll try to do it together collaboratively. Like I said, we'll see how it goes. Another thing about today, it will look like we're working with APIs, but what we're going to actually do is create a test plan, thinking about cases that are functional, that are okay for APIs, but also for other things as well. So it will be like an exercise of coming up with test cases. And I think that's a very interesting thing to do. So let's start. Like I said, I'm Gil. I'm a trainer, I'm a consultant for everything about creating better software. That includes, of course, API, testing, live, stuff like that. Learning as well. So I do these kind of webinars, and I'm the author of 2 books, Everyday Unit Testing, Everyday Spring Testing. And today, what we're going to do is taken from something that I do in all kinds of workshops, whether it's clean code or TDD testing, unit testing, or for API testing, which is kind of skewed towards today. And the idea is that how do we come up with test cases? So let's see. I'm going to start with, if there's a question, okay, rules of the trade. First of all, there's the chat window. We're going to use that. There's a question, are the webinars recorded? All the webinars are on my YouTube channel. And you can go to my site, everydayunittesting.com or testinggil.com, which will get you to the same place. And you can get the recordings from there as well. This one will be there as well. So APIs. You look at an API and say, well, how do I test that? We're starting with a given thing. And let's say that I'm creating a user like this. How do I know that it works? Well, I may look at the result or something like that, but is it one thing that I do and then I say, well, it's tested, it's okay? What kind of things can I look at the signature and ask, well, what kind of cases do I have? So if you look at the screen right now, we can start at no users or no users named Gil, or some users from the same company that are not called Gil, or some people with the first name Gil but are working in other companies. This is just looking at this thing in the API. There are kinds of cases that we can come up with. Some of them will be relevant. Some would be relevant but are less important because maybe they are covered by other cases or not that important in terms of usage. So we're kind of thinking about, the starting point is, of course, an API, sometimes, mostly, a documented API tells that this is how it should work. But with a single API, we can think about like different cases. Here's another example. I gave that a while back. So yeah, you shouldn't post passwords and usernames like that, but for the sake of our example, let's say this kind of thing, you're trying to log in with the wrong password. So this kind of an API, you have query parameters, you can do it once and it's okay. So that's a successful or non-negative or happy path. Not going to talk about happy paths today, but let's say you're trying to check what happens when you're doing a wrong username or a password. So the behavior of the API can change depending on how much you're going to use it. So for example, assuming this kind of thing is documented, so it's not like magic, but you want to see if it works, and you try to log in the first time, don't succeed, get a message, incorrect password. Try to do it again, twice. Then it says incorrect password, you have one more try. So different behavior. And the third time you try to log in, it locks everything out. So it's not just the API that doesn't work now. The login API, all other passwords have changed behavior as well. So same API, same parameters, but different behavior every time. And let's compound on that. What happens if this locking mechanism goes out after an hour? So there's also a time difference thing that we might want to check out. So basically what I'm trying to say, no, not that, this one, that APIs are complex. They are complex because of their structure, the kind of data they are passing, like header fields and query parameters and bodies. We can play with that as well. What are fields? What kind of fields? Necessary fields, unnecessary fields, optional fields. What happens if we send a completely different body? What happens if we send a completely different format? All this are relevant things that we can come up with and say we'd like to see how the system works. And that's just how data is transferred, right? XML instead of JSON. We can also think, and this is what we're going to think about today, in terms of functionality, how the system works. So you've already seen that I said we're going to test APIs, but we're not really testing APIs. We're testing features. We're checking that features actually work as we expect them. I talked about it in other session before. Basically, there are two things. When we talk about planning, we're kind of thinking about two things sometimes together. There's the test planning part and the test design part. The test planning part is coming up with test cases. And maybe, we're not going to do this today, some kind of prioritization out of the list that we compound, which are more important for us. So in this case, what we'll have at the end is a list of things that we'd like to test in some way. What is this some way? That's the test design part. Some of them will be unit tested, some of them API tested, some will be composition of that. Some of them will be manual tested, some of them will be automated. You can think about whatever you do based on cost and value, really. How much is it worth automating this stuff? If things are changing all the time, is it worth it? If this is like a very important feature, yes, we'd like an automated test that will run, maybe an API test that will run all the time as a regression, rather than the unit that checks that the data is sent correctly to the database, which is not that useful. So that's test design. We're not going to talk about this today, but if you go to former webinars, I did a whole thing about API test design, so you can go check that. Like I said, I talk about this in different kinds of courses. If you're interested in me helping you in kind of workshops, courses, stuff like that, let me know either directly today or go to the site and or email or whatever, and check out if there's something relevant for you. So what we're going to do today is I have this calculator here. A lot of testing examples start with calculator. This is a bit different because this is a 90s calculator. Why is it a 90s calculator? Well, if you open this, if you have a calculator up here on your phone today, if you do 4 plus 3 without pressing the equal part, the equal button, you'll already get a 7. Why? Because calculators are smarter than us today. In the 90s, we were still a better species, but unfortunately, that's not today. So, so this is like an old school calculator. It doesn't do much. This is the UI. It has basically 2 APIs. One of them is press, which is when you press the keys. And the other one is the get for the display. So basically it looks like, hold on, something like this. So the API is a press with a parameter of what I pressed. It could be like 1, 2, 3, or plus or equals. And we have a get API, which returns a string containing the display. This is everything that we have. A bit about the calculator. For the people who haven't tried 90s calculators yet, this is an awesome experience. Pressing any digit, the display adds that digit to the existing display. So the exception is 0, because if you press 0 and then another digit, it will just show that digit, doesn't add the 0 before that. What else? Pressing an operation key does not change the display, because we're interested in the calculator itself, but we're more focused on the display, what it shows. This is the API that we're giving. So pressing an operation does not change the display. Pressing C resets the calculator, and pressing equals shows the calculation result. That's basically it. If you need other things, I'll be the product for that. But what we'll try to do now is basically build a test plan. The way we're going to do this, like I said, interactively, is you write things in the chat window, and I'll hold up, which I killed the chat window. Not what I wanted to do. Let's end the slideshow, and I'll put on my trusty notepad so we can write test cases. So give me an example of what you would test, a test example. Write them in the chat window, and I'll write it and I'll discuss what it happens. For example, let me get things running. So just you'll see, if we're not doing anything at the beginning, it shows 0. Cool, right? Yeah. Operation as first button. I'll be reading from the chat and I will be very annoying. So we're writing examples here. That's our examples of how we're going to use the code. So please, when you're saying something operation as first button, please write me an example of how you're going to do that so I can write it here. Your turn. You should write things in the chat window. So pressing 1 will show you 1, something like this. Yeah. Yeah, exactly. So that's a very simple thing. We want to do that. So let me ask you this. If I do this, do I need to test this as well? What do you think? Right in the chat window. No need. Anybody else? Another opinion? Not yet. So again, this is, I'm going to ask questions, so you probably want to be more interactive. Otherwise, I'll be talking to myself. So here, execute some. So hold on before I go there. So I could do this and this and this as well, right? And the question is, should I? And if we're talking like black box completely, and there would be no assumption or no knowledge how the code is written, well, 1 is not like 2. But if we're writing the code and we have an idea of how the code works, or we have an assumption of how the code works, then we would say that we probably don't need 2, 2, or 3, 3. So this is what we call like segmentation, right? So these things, or classification, these test cases are like the others. So we can actually decide whether we actually do that or not, but there's some kind of risk involved, right? Because it might not be. So we need to think about cases like this. Next, there's execute sum. I'll need an example. Meanwhile, there's this. So this is like another class of things, right? So if this was like on start, this is like pressing digit. And this one is like pressing digits, but with 0, 1. So 0, 1, we expect to have 1. And that's true. And it's checking out the rules of the digits. Is it completely like this one? What do you think? So there are two things that are different from here. The first one, oh, there's no press and there's no decimal button. Sequence. So first of all, we're doing two things here. First of all, we're pressing 2 digits. That's an upgrade from these two. So this is more like, for example, this. Okay. And obviously we can start having more and more digits written, but this also starts with a 0. So this was a special case because 0 is different than other things. So all the rules that apply here, this is a bit different. So we want to see that. So is this pressing digits? Yes, but with 0 at the beginning. Okay, what else? Sequence is important. That is true. I wrote a decimal thing, but I will something like this, but we don't have a point here, a decimal point. Let me show you the UI like this. So here's a question for you. Is it possible to call the APIs like that, even though the UI does not allow it? And the answer is yes, it is possible. So this is very interesting because we don't think about it that much. But yeah, then I showed you the API. It looks like this. Where is it? I can pass anything I want here. So even a decimal point. And based on that, I'll be the product here. Yeah, it will look like this, but it's not really important right now. It's more important about the definition of what is true, what is we're expecting, and what it is. It is possible to send this thing. Okay, so that will be not in the UI stuff. Yes, what else do you think? There are a lot more cases. Large sequence. What? Whoa. Hold on. A couple of things. So I have first large sequence. What is a large sequence? Okay, so what you're I'll be with you in a second. So is this large? Well, that depends of how much I can actually put in the display, right? So if I'm checking the display, what kind of thing? Like let's say that I have 5 digits to display. What can I? What would be a good test case? So there's 99999, and there's the 100. So if I have 5 places in my display, so this would probably show this, and that's okay. And then this. And if I'm checking the display, could you think of another? It's okay, but we're kind of expecting 2 things here: either this or this, right? Or maybe we'll be surprised on something else, whether we shift things left or right. So we'd like to check the display in that, right? Excellent. Hold on. I'm scrolling up. You're too quick for me. A bad request. So you probably a bad request is something that is a result of something. So we need to see something that tells you this was a bad request. That is true. 1 plus C, 0. So plus C. Sorry. 0. So this is the realm of resetting. So we are assuming, and that you're probably assuming correctly, that pressing C zeros in. I told you it resets the display. Basically it shows 0. So this would be under the resetting part. So that's true, and we probably have other things under this resetting here. That is true. Typing 6 digits. Can you give me an example? So this is typing like 5. This is typing like 6 digits. I counted them on one hand and one finger. So yeah, this will give us like something that shows us how the display works when it's limited to 5. We need to understand the limitation of the display and then what we're showing there. We'll be back to this in a minute, but there are a couple things from Dinesh who wrote these things. So -1. So I'll show the again the calculator. So we have a minus and we have a 1, but if when we're pressing minus and 1, are we really what do you mean by that? Is it just an operation and then it's 1, or are we actually meaning -1 and like Dinesh wrote, is this thing or minus as an operation? So we need to know about this. This is an old school thing. It doesn't have a minus operation, so it probably will show this thing. But here we're coming to another category of things. First of all, operations, but also minus has a very distinct thing about it. So if -1, we have like operations, like in general. So +1 will show 1 as Dinesh wrote, and this one as well. So operation starting from the beginning just shows the last digit because it doesn't change things. But if that, like we said, minus is a bit different because it might have another meaning in our domain. So far we have many categories. What else do we have? So we have operations, for example, like we started from 0, but we can also check what happens like this, right? Because we said that operations after the number doesn't change the display. So we can have that as well. Okay. And what happens when there's a number operation number, like 2 + 4? What's that supposed to do? Two plus 4? No, you fell into the trap. 2 + 4 equals is 6. No, 2 + 4 shows 4. Unless I write well, there's the whole calculation part when I actually do this. Sorry, this. And then I'll see 6. Okay, so it's a very interesting trap because we're kind of thinking like a calculator today, right? We're continuing the calculation, and it's not completely that. Okay, division by 0. So first of all, let's talk about division in general, okay? Because it is like an operating, right? So let's do a calculation first. Something like this. This will probably show us 2. Okay, now division by 0. So 2 equals 0 with equals. Right. The division is a bit different than plus, minus, or multiply, right? Because this will need better taking better care of that. But division also does another thing that we might want to check. What, for example? So, for example, if I do this, Radislav is ahead of me. So, what does it do? First of all, it can round up, round down, something like this. Or it can round up. Or maybe it doesn't have a decimal point as an entry point, but maybe it can show it, like we had with the minus, because with the minus thing, didn't show it, we could mean like a -1. So what we show and what we are able to get as an input may not align depending on the features themselves. So this also can be like 1.25, depending on the definition. So the division is not only difference in terms of operation, but it allows us to think about cases that will be displayed that may not be inputable things, which is interesting. What else do you think? So we talked about minus and calculation. Let's talk about calculation as well. This is nice, but we can do first of all with 3 operands, right? Does it work? Triple operations, and we can continue with that because it's interesting to see if it works. Again, we kind of have this kind of feeling that it's a calculator. Obviously, it does what it's supposed to do, right? But as a tester, I'd like to know if it does. So we can do this like triple operations, not the same operations, multiple operations, so on, which brings us to the order of operations. Complicate calculation with parentheses. Okay, so we don't have parentheses, but we can have something like this, right? So what is the order of things? Without parentheses, we need to define whether it's 43 or something else, because calculators in the 90s were kind of stupid. It could show you something like this sometimes. So well, it's not stupid, it's not developed. So we can talk about this. Okay, so this is an interesting one. So what Radislav wrote was 3 plus this, and this. And the question is, well, there are 2 questions here. First of all, well, which one? What's happening? What's the behavior that we're expecting? Do we ignore the plus? Do we ignore the star? Or can take it further. What is the meaning of this? So, for example, I can say that this is basically, if I'm choosing the plus, that means that any operation after the plus doesn't count, right? So it could be like 11. Or I can say, well, the meaning of that is that the user may have done a mistake, made a mistake. And therefore, I should ignore everything about it other than the last one, which will show me 24. So I can allow calling different APIs in a sequence, but there's some kind of domain meaning attached to it, and I need to understand that. Now, it may be that it's not documented anywhere, but that's why there are product people who can tell you that. Let's see what else. C keyword, I don't understand, waiting for an example. 3 plus 5 equals 0 equals. So the part in the division, where the division by 0. Let's move it to a new apartment by 0. It will be here. And with it, another example, what happens when the error is in the middle? So 3 plus 5 equals 0. Something like that. 2 things happening here. First of all, the error obviously happening here. Okay, so that's one thing. But here's another thing for you. This will probably show something like this. Okay, or it can show something like this, right? I'm ignoring the error. So, but what happens, and I'm going to start with a simple one here with the calculation. So what happens if I do 6 divided by 3 equals plus 2 equals. So this is a continuation of a calculation from starting from the result of the first one. So we need to think of that as well. Let's see what you wrote in the middle. So Christoph said something similar to the -1. Where is it? Something here. 3 times -2. What is the meaning of this minus? Is it -6, or we're ignoring one of the operations and doing something else? Division multiplication yielding exponential components. So we talked about this, not exponential, but where's the division? My division. Something like this. So it's not multiplication with probably a big numbers and something like that. And but we talked about fractals and stuff like that. We need to define what is the true thing. If we can provide 100,000, then what happens when 100,000 times 100,000? So let's go back to our display size. So there are 2 parameters here. One is what the display can show, but also the memory size. So one thing we'd like to see is, for example, if we have 5 things in the display. So let's say we do this, right? So what will happen is that the result is probably 100,000, but A, can it calculate it? B, can it show it? Because if it cannot calculate it, you'll probably see an error. What happens if we do this? Same thing. We're trying to create some kind of an overflow, and we're testing the memory side plus the display. So we're checking things together because we don't have any access to the memory right now. But yeah, if we can define what the memory size is, we probably want to see what happens when we overflow that. And if we're going into bits and bytes, what if it's integer or assigned integer or stuff like that, then maybe the memory size or the memory limit we might change. So that's true. The display size and the memory size are different things that we'd like to check. Yeah, what else do you think? So around the division, we also can do something interesting else that we didn't see. So we had this that we said, well, it depends on what the result is. What happens if I continue from that? So 5 plus 1. So continuing an operation, or same thing. What happens if we're continuing from a result that it was either rounded and or decimal? Do we want to see that ripple to the next calculation? -1 plus 2. So this is one of the minuses thing in part of the calculation. So -1 plus 2 equals. So this is sort of like a minus thing, but what happens if it's like this? If I told you that there are no negative numbers, what is that? And what is that? So not just showing negative numbers, but are they flowing to the rest of the calculation? Because we'd like to see that. Okay, next one's complex. 1 minus 2 equals. So this goes back to our category of something like this. What do you mean by that? So the question is whether we ignore, or maybe minus minus means plus. Very weird calculator. So what's the definition of what is the meaning behind two operands, the two operations? Okay, I have some category we haven't done yet. We touched on it. So any other cases you want to think about? Okay, so first of all, what happens? We touched about it, about the dot. Remember the decimal point. And where did I put that? Not in the UI. So we can send something like an alphabetical thing, or maybe an ASCII thing, or something in another language, like something with an, I can't do this. Maybe I'll here in Hebrew. What happens, because it's an API, it's a string, whatever it gets, it can actually send through the API. So we'd like to see things like that. It is possible to do that. Another thing, what happens if I send, it's a string, right? It's a query string. It's like this. In terms of an API, I can put anything here, but also a complete string. So it could be like, if I not send press 2, press 3, but 2, 3 as the parameter. So it is in the UI. But instead of calling the API 1, 2, 3, I call it once with 1, 2, 3. And again, this might be a behavior that is defined or not defined in the API, because maybe the developer was thinking ahead, said, well, if they send me something like this, it is like they're sending press 1, press 2, press 3, and then maybe I will show 1, 2, 3. Or not. Maybe it just recalls the last one or the first one. Don't know. It's a behavior thing. But if we're thinking about sending a whole string here, what happens if we send, I don't know, the entire Encyclopedia Britannica? Meaning, that's a whole bunch of characters there, and there might be a limit there. And we're trying to see what is the limitation of the server. So probably we can't send the entire Encyclopedia Britannica, but a full web page of Lorem Ipsum could work as well. So think about what is the limitation of this query. We can try different sizes of things. Or we can do something like this. We're sending a string, right? Well, how about maybe we're something inside, if we knew what kind of tables are being used, maybe we can try to hack the system because we're able to send strings. Equals show 0. So that's basically starting operations on the beginning. We had something like that. Yeah, let's say it's this category. So what happens is that not immediately on start, but this is an operation on start. So yeah, any operation on start, we're expecting it to show 0. So that too. Any other things? So as you can see, this like I showed you a couple of examples. We came up with a couple of more things. And what we did as an exercise, 1 equals 2. 1 equals 2 is what happens after a calculation. So I put it under here, but it's actually another thing. It's more like this category, because after calculation, what happens? And as it was rightly been said, 1 equals 2, because the 2 overrides the 1. That is true. Sending URLs. This is possible as well. It comes back into whatever string we're sending here, URLs as well. Does it accept it? Does it throw an error? Is it forbidden? Is it not forbidden? How does the application do that? Anything else? You'll think about it, you write it. I'll try to summarize what we did here. So basically what we started with, 2 APIs. I showed you both of them. And I showed you a couple of requirements, but I didn't show any documentation, because most of us worked with computers and calculators before, or phones, and know how they work. But if we start like thinking about what we're actually doing within the constraints of the UI, we're starting to see that there are different cases that we'd like to try and see how the system works. Remember, it's not how the APIs work, because the APIs may be working in some way, but we probably need both of them in order to see how the system is working. So we're basically testing features. We talked about different categories, categorizing stuff. And just writing stuff on the wall. You said this is not like a very formal way of writing test cases, because it's easy to write a shorthand for that. But we came up with a very nice plan and very comprehensive one. And the reason we came up with a comprehensive one is that it was a collaboration. We built one on top of each other. And so we had references of other ideas as well. Specifically here, it's very easy. I push you to it, to think in terms of examples. We need to turn, any test is an example of the system usage, right? So we need to think about it this way. We put some names on categories, and we talked about how is this different, or is it the same category? Because if things are the same category, we may maybe get a discount. Like, well, what this example represents other examples as well, like 1 through 9. If we assume that it's going to be the same code from all the digits. Of course, 0 may not be the same thing, so we need special cases or special test cases to check. 0 in the beginning, and the more we had more examples, we had more categories and more discrete categories. Like this is like this one, but it's different. 1 equals is 1. We had something like this now. Not completely, but maybe here or in calculation. Yeah. 1 plus 2 equals. Yeah. Well, it's the whole category of what do you mean by equals? Where do we stop? Is it still? I think it's not. That's not a good example of continuation. But it could be like what Christoph said is something like this. So are we going to display the same result every time, or are we doing something with the result? What you could think is like this. So this is something that I had in a calculator before. So this basically, up until now, we didn't have this. Okay, so this is a something by itself? Does it take the 2 into calculation even though I didn't press 2? And this one says, well, you meant 2 to the power of 2. Does equal continue this pattern? So where is the pattern and where does it continue? So this will be like another pattern things after calculation. So even though we were finished, we're still coming up with more cases because this is a complex thing. It doesn't look like it, like 2 APIs, everybody knows a calculator. When you start thinking about it, there's a lot of things to test. So, and we can think about different examples for each category. And I can tell you that you can come up with other stuff as well. And you probably can, and you probably will after this is finished. So let me sum up. Let me get back to my slides. You can continue thinking about other things. I'm still open to that, so I won't stop you. This is a very small example of something that we are familiar with and very small set of things to play with. Although the APIs, although there are 2, and we use the display only once. What happens if you do press display, right? Operation. It can get very complex. So whenever we're testing APIs, we need to think about, first of all, the feature, the system itself, what we are actually testing. And you saw that we already start like putting like not just inputs and outputs, meanings behind it. So we need to think about that. And once we have this kind of very big list of what we think is this is a good thing, then we need to look at our watches and say, well, how much time do we have and what is important here, what is less important? Because maybe it's very important that equals work, but C in all kinds of cases, like the reset thing, may not work. And we don't have time to check everything, but we can check some things. So out of this list, we can decide, well, this is what is important for us and what we're going to do. So this is the planning part. Like I said, after that comes the design part. Which of the things are we going to test where? And as you could see, like if you're just working on it by yourself, it will probably still look like this. But if we're doing this in a collaboration, if we're people working like throwing cases and looking at what was the result and then coming up with another case and say, oh, we tested that, it's like this one, or not, this is like another thing. It's an iterative plan, it's an incremental thing, and it's possible and to work to a bigger plan. And the more complex things are, we are not working on calculators, the more things, and we don't know, we can have more questions. We can ask, well, what happens? What is the meaning of that? You saw that we kind of went from the API back to the user. What does it mean when we're pressing minus plus? Which one should we take? And this is, by the way, something that the developers should ask as well, right? If I get a plus and then one and then a minus, what is the code that I need to write for that? But as tester, we'd like to see, well, is the expectation the same thing as we get from the thing? This is what I wanted to do with you today, and it went quite well as an experiment. So thank you for collaborating with me. The idea for this is like show you how this looks like when like it's very simple. When we understand the domain and we are in the same headspace, but we still come up with different things and more complex things the more we ask more questions. And this is what I wanted you to at least experience today. Like I said, there are courses for that. And if you were interested, and I can talk about task planning for a whole day, which I do, sometimes for money. But other than that, I want to thank you for coming today. If you're interested in anything that I showed you today, more questions, here's how to get me get in touch with me. Thank you for coming today. Thank you for playing this game with me, because I like playing it very much. How something that looks very simple we can come up with a lot of complex ideas and things to test. So other than that, thank you and have a good night. Hey everyone, if you enjoyed this video, be sure to like, share and subscribe for more. Thanks for the support, and remember, live long and test.